Welcome protein coders, let's build some coding muscles. Earlier we have studied how to do a point update. If you have given an index and you want to update the element at that index. Today we're going to study range update query. If you want to update a complete range, a whole range, you want to update. And we will use optimization, lazy propagation in that. And we will see. Okay. So what range update query means is, let's say we will be given LR and value. L and R are the indices, the range in which we want to increase the value of all the elements by 1 or perform any operation, not necessarily the addition operation only increasing, it can be decreasing also. Okay, so today for simplicity we're gonna assume we are performing an increasing operation. Okay, now let's see in our segment tree how we're gonna implement this. Here is a segment tree and our array. Okay, so as we studied while performing the point update query, we will perform a few similar steps. Okay, so here we are given segment index, segment start index, and segment end index. Okay, for every node. Now we are also given the query range or query update range L to R from 0 to 4, and we have to increase every element value by 1. So query range is inside the segment range, and we have some elements which we want and some we don't want, so we will move both sides of the segment tree. Okay, left side is 0 to 3 is completely inside the update range, so we will perform some operation, we will see it later. Okay, let's move to right side. When we get an element 6 to 7 range which is outside the query update range, we will simply return, right? So till here, for two cases, for partial overlap and for no overlap, we know what we need to do, right? It is similar to the point update query. So let's write the code for this, and later we will see what we do when we have query range completely inside the segment range. Okay, so let's write code for these two cases first. So first case will be if our query range is completely out of the segment range. Then here in these cases we will simply return, we will not do anything. Or else if the query range is completely inside the segment range, then we will see later. Okay, and third case, when there are few elements in the segment range which we want and there are a few elements which we don't want, there is a partial overlap. In those cases we will find the mid and recursively call the function for left node and right node. We will search both sides of the node, and while returning we will update the segment tree, right? Segment tree node with the sum of the children nodes. It's very similar to the point update code, right? So this case is for no overlap, this case is for partial overlap, and for the complete overlap, let's see what we need to do. Okay, so let's see in the segment tree. So in our segment tree, we have left the cases when the segment range is completely inside the query range. Okay, so we have two cases for this, the node at index 2 and node at index 12. So let's see the case for our node at index 2 having the value 11 and the segment range is 0 to 3. So in 0 to 3 there are 4 elements, right? 3 minus 0 plus 1, and every element will be increased by a value of 1. So the total increase will be the total number of elements 3 minus 0 plus 1 multiplied by the value. So what we will do is we will calculate the net change in the sum here only and we will return. Okay, so let's calculate the value. Just 3 minus 0 plus 1, number of elements in that range, segment range, multiplied by the value, which gives us the net increase, which is 4. So we will update the value of this node by 4 and we will return 15. But before returning 15, we need to propagate this idea, like in future in any further queries, if we need to go below this node for performing our query, we need to remember that we have to update the value of the segment nodes by some value. And this idea of propagation and early returning is what lazy propagation is named after. Okay, lazy means we are returning early, and propagation means in future if we need to propagate beneath that node, we will remember that updation. So for this, we will use a lazy segment tree. Okay, in this, for every indices like here, we have propagated the update to index 4 and 5. So we will increase it. So in future, if these nodes are visited again, we will perform the updation again. Okay, and for the segment tree node at index 12, you see it doesn't have any node beneath it. So we don't need to propagate also for these cases. Okay, so we will simply update and return the value for such cases. Okay, so now we have updated all the values, so we will return the updated values. We will get the segment tree nodes as some of their childrens, right? So finally we have updated our segment tree. So for this operation, if I write a code, let's say I call this function push, which will have the segment tree index, the start and the end of the segment. Then how I gonna perform this? First, when I reach this node, I will increase the value in the lazy tree. Okay, and if I found it's not equals to 0, this value, I will first calculate the updated value of the segment tree node. Okay, which is number of elements multiplied by the value which is already present in the lazy index, right? And then I will propagate it, but I don't want to do it for the elements which are at leaf. So I will check first if the current segment tree node is not the leaf node of the segment tree, then I will propagate this idea via lazy tree. So I will increase the value in the lazy vector. And finally, because I performed the updation for this lazy node index, I will mark it 0, right? So I updated the segment tree node and also propagated the updates to its children. Now suppose I want to perform another update query from range 2 to 5 and increase the value of each element by 2. So similarly, I will check 2 to 5 is in the segment range. So I need to go both sides. There is a partial overlap, right? And when I come to the left side, you see 0 to 3 is again, it's partial, is doing a partial overlap. So again, I need to move both sides, right? But from here, when I reach the node at index 4, this I found there is already a value for this in our lazy vector. So first thing is, whenever I visit a node which has already having some update, pending update in the lazy vector, I will update this first. Okay, then I will check for the further operations whether I need to update it or not. Okay, so whenever I visit a node which is already having some pending updates, we will check for the lazy eye, then we will perform our push operation which we have studied here. So we will increase the node at segment index 4 and 5 first based on the pending update. Okay, and we will propagate the update also, that we have increased this by a pending update value, right? And later on, after doing this first update, we will again check the node at index 4 having the segment range 0 to 1 is not in our query range. So we will not perform any further updation value here and we will return. But for the node at index 5, it is inside our query range. So we will again perform this push operation. Okay, we will again calculate the updated value for this node at index 5 and propagate the update value, which is now in current operation is 2. Okay, so similarly we will update our segment tree. So from here we got two observations. First thing is, when visiting a segment tree node, we will check first if it has some pending updates, then we will perform this push operation, that update the segment tree node and propagate with the pending value. Okay, and second case is, after performing the updations, if the segment tree node range lies in our query update range, then we will again perform this push operation. Then means we will again update the value and propagate with the new value in our query. Okay, so let's see this in our code, how we gonna implement this. So when we are completely inside the segment tree range, node range, we will mark the lazy eye with value and perform our push operation and return. Or one more thing, when we reach any segmentary node, we will first check that if there is any pending update remaining, we will perform push first. Okay, so first is for pending updates, first push operation, and second is for update and propagation for the current query. So in update range query, you just have to keep two things in mind. It is very similar to the point update query, but here first we will perform the push operation every time we visit a node, and in case of complete overlap also we need to perform the push operation. And in this push operation, what we are doing is we are checking if there is a pending update in the lazy vector, we will increase the value of the segmentary node, and if it is not a leaf node, then we will propagate also, right? So this is the propagation part. So that's all from my side, guys. I would urge you to take an example and try run this code once. I mean, not urge you, I mean it's a must, you should. Okay, we will do a few questions on this so we can have a better grasp on this topic. If you have any further queries, please mention them into the comment box. I hope this helps. So let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.